Hi, I'm Mr. Huber, and in this video we're going to look at problem 2a and b. Well, this is very different because now we're given a function in general form in a and b, and we want to rewrite it in vertex form because it's not easy to know what the graphs of these functions look like. Okay, so let's start with the first one. F of x is equal to x squared plus 6x plus 9. Well, in this case we're lucky, because this is nothing but a binomial formula and you could write it like this. Well, that means f of x is in fact x plus 3 squared plus 0. So it's nothing but a horizontal translation by 3 units to the left. So the function looks like this. 1, 2, 3 to the left. And you know, well, the y-intercept is at 0, 9. So you could have that one up here. Here we go. So it would somewhat look like this. And this would be 9. See, it's not very exact, but it doesn't have to be. It's just an idea of what the graph looks like. Quite easy. Okay. Now, well, the next one seems to be a bit harder. Look, it's f of x is x squared plus 6x, but now plus 12. Well, that's not a binomial formula. So what do we do now? Well, first you could notice, because you've done this one, you could say, well, why not write it like x squared plus 6x plus 9 plus 3? Well, then this is now again x plus 3 squared. Why not? So that would lead to x plus 3 squared plus 3. And now it's more or less the same function as the function before, but now it is, in addition to a horizontal translation 3 units to the left, it will be translated 3 units up. So it will probably look somewhat like this. Here we go. 1, 2, 3. This is going to be 12 up here because that's the y-intercept, 0, 12. So the vertex is at here at minus 3, 3. The vertex up here was at minus 3, 0. So now 1, 2, 3. So this is going to be your vertex, and the graph is going to look somewhat like this. So try to have a rounded and smooth parabola here. It's not perfect, but well, it's more or less what we need here. Okay, so this is the vertex. Now look, we were able to do this because we did this one first. But let's say we had not done this one here. Now look, how does a binomial formula work? So it works like this. X plus a squared is x squared plus 2a x plus a squared. So what do we notice? We notice that the number here is in fact twice the number here that's going to be squared. Okay, so why can we use this? So you could say, let's start with f of x, x squared plus 6x plus 12. So we could say, let's just add something so that it's going to be a perfect square. That's x squared plus 6x plus 3 squared. Look, we're going to halve this number, divided by 2, which is going to be 3, and then we're going to square it. But we're not allowed to change this function, so we are going to undo this, okay? So we add 3 squared and we subtract it right away, and the 12 in the back remains, okay? Well, this is called completing the square, because now we have added the one thing we want, And we've subtracted it right away because we're not allowed to change the function. And well, in the end, we write what we had before, the 12. So now I can say, well, this in fact is going to be a binomial formula. F of x is x plus 3 squared minus, well, this is minus 3 times 3, so minus 9 plus 12. And now f of x is going to be x plus 3 squared plus 3. Look, at first we started like this. We noticed that this is a binomial formula. Then we did this one and we said, well, this is very close to the first one. So why not just split this up and say, well, it's 9 plus 3. Well, this is a perfect square. Or if we hadn't done these two before, we could have said, well, a binomial formula works like this. X plus a squared is x squared plus 2ax plus a squared. So the number here in front of the x is always twice the number that we're going to square back here. So if we wanted to make this a perfect square, that's why it's called completing the square. We want to complete the square. So we add half of this and we square it. So this will be a perfect square. This will be a binomial formula. But we're not allowed to change it. So we subtract the 3 squared right away. And we leave the 12 untouched from before. So this will come over here. It's untouched. But we've just completed the square. So by doing nothing in a very intelligent way, we're able to rewrite it in vertex form. And then we get this. Hope it wasn't too difficult. See you on the next one.